Hello, friends. Let's go on XPCIE1032H Quick Start Series. Today, Lesson 5, How to Configure XPCIE1032H Card I/O. For more knowledge, please check corresponding videos and articles. It will be talked from 3 aspects. Part 1, Introductions and Preparations. Part 2, C# Routine Description. Part 3, C# Routine Operation. Okay, begin. Before that, please see this form. XPCIE1032H card itself supports 16 general inputs and outputs. If you need more, 512 can be extended. This will be mentioned later. And it can be known too, and signals can be configured as single-ended encoders. 4-out signals can be configured as single-ended pulse. Then, this is the theme. Around these 2 functions. How to configure in as encoder and how to configure out as pulse for XPCIE1032H card I/O or extended I/O by expansion module. Here shows XPCIE1032H card itself I/O descriptions. Axis 0 and Axis 1 can be configured as encoder or pulse. But Axis 2 and Axis 3 only can be configured as pulse. In real applications, sometimes, more I/O will be needed. You can choose to expand some. Zmotion provides specialized EtherCAT I/O modules. EIO16084, you can get extra 16 inputs, 8 outputs, and 4 pulse axes. EIO24088, more resources than 16084. Also, coupler type is supported. Zmotion communication module plus submodules that are with enough I/O numbers. Please note multiple modules can be used. That is, connect them together. Not out of max range of the motion controller. For example, XPCIE1032H card only allows 512 I/O. Accepts Zmotion modules, if you have other EtherCAT modules. Still valid to obtain required resources. Now, in this lesson, use EIO16084 to do showing. See, 16 inputs and 8 outputs here. And there are 4 pulse axes on the board. They all can be set as differential encoder input and differential pulse output. Each axis is 1 dB26. This gives pin definition. Encoder in and pulse out. EtherCAT in and EtherCAT out both are used to expand. In is for former station. Out is for next station. Don't mix them. Okay, basic theory is learnt. Next, specific I/O configuration method. XPCIE1032H card itself I/O at first. How to configure in as encoder. Step 1, wire card to encoder. This is the example. In 4 to in 6 are used here. Step 2, set a type. Before that, please confirm the type according to the form. Because it is quadrature encoder. Set a type is 3 through axis number. Then, how to configure out as pulse. Step 1, same, do wiring. The example uses out 8 and out 9. Step 2, set a type. Here, it should be type 1. Also, set it through axis number. If there are I/O and pulse axes expanded by EIO16084. The important step is to wire them. Like this, connect them through EtherCAT. The card only has 1 bus, EtherCAT. So slot is 0. 4 slave devices are connected in order. They are called node. Under each node, 1 drive is connected. Then, it will be drive. Because they communicate by EtherCAT. EtherCAT drives. It can be known the 5th device is EIO16084. It only has pulse axes. Connected are pulse drives. After wiring, it is time to configure extended I/O. Actually, methods are similar. Step 1, please do wiring. Here shows in wiring. Connect the card and the encoder correspondingly. Different encoders, please check the manual. Then, here shows pulse wiring with Panasonic drive. Also, connect them with this guidance. Step 2, restore a type. Specifically, read ReLA type and set it by data dictionary. Because after wiring, it will be EtherCAT CSP mode, the A type is 65. Then, the data dictionary is XPCIE1032H. This is the command. If the type is 1 after reading, then here writes it as 1 by node and slot. See the example codes. Okay, until now, the part 1 is over. Next, let's enter C#. Check how it configures in this C# routine. And this shows the process. See 1 by 1. It can be seen there are 5 aspects. This aspect SDO reading and writing is mainly for extended I/O. Let's see together. At first, connect to card through local. It was mainly talked in lesson 2. Then, it will update and show state by the timer. Next, click this to choose EtherCAT initialization basic file from your PC. Download it into the card by C# function calling. Also, it was mainly shown in lesson 3. You can know the initialization state. If not finish, it will show not finish. If already over, corresponding information are shown. Now, remain the most important parts. Before motion, set basic axis parameters. Whether to change one axis. If yes, please modify the global variable. Then read corresponding axis parameters, show them in UI. If you need to modify the axis type, this C# function is used. When Modify button is pressed, it will be called automatically. Next, you can operate axis motion. This function is for motion. Corresponding stop motion is this. Then, back to UI. Forward button triggers the motion function. It will move forward continuously. Reverse is opposite direction. Motion can be cancelled by stop button. When you connected XPCIE1032H to expand I/O and pulse axes. After initialization, use XPCIE1032H to set ReLA type. Read it at first through SDO reading command. In this way, correct a type can be known and set by SDO writing command. After that, please remember to read again. See whether it is configured. Let's run it. As usual, start MotionRT 7. Back to C# routine. Start it also. Connect to card by local. Connected. Choose initialization file. Now, initialized. It shows 4 EtherCAT axes. Map them to axis 6, axis 7, axis 8, axis 9. Now only configure card I/O. Therefore, 65 is okay. The card is EtherCAT type. Former mentioned, axis 0 can be configured as encoder in and pulse out. Therefore, we choose axis 0 here. For pulse, the A type is 1. Set it as 1. Click Modify directly. Now, configured. It is time to move it. Forward. Reverse. Try to encoder type. Set it as 3. All data are cleared. Let's manually run the encoder. Obviously, it is running. Next, see how to configure XPCIE1032H axis. It is pulse type, but now A type is 65 bus type. A type should be corrected. The key point is data dictionary XPCIE1032H. Note, please write the decimal system. Corresponding value is 24,593. Read original type. It shows it is a type 7. Pulse type. We write it as 1. Then read again. Okay, correct type is configured. However, no action after forward or reverse. Because it exceeds hard position limit. No problem, clear the alarm. Open RT sys or zdevelop. Also, connect it first by local. Set corresponding limit as -1. Which means not to map. Okay, solved. It can move. Try encoder type 3. It can be seen MPOS becomes 0. Manually move the encoder. It is changing all the time. In this way, configuration succeeded. From now, card I/O and extended I/O configurations are shown. Today lesson 5 is over. You can check the article together in website download page. Thank you for your watching. Lesson 6 is coming next week. See you next time.